Okay, I know it's the last talk of the day, so I'll also keep a note of the time also. And make sure I'm not boring you. The idea behind this talk is not to give everything what is available in the area. I know that this term is overused. You turn the third page of Times of India, this is the word which you see everywhere. So I don't want to use it that way. Okay, I'll be more, how do you do this? And it is not a big thing. Okay, so that's the idea behind the talk. I just want to say that it is easy to do and you can do it in .NET or any language which you wish. Yeah, so I like to start with the famous guys like Google. This was in 2007, I believe. There is a prank by Google which says that going forward, we're going to reply to all your mails. Okay, so if you type a mail, there is a mail came to you, it will automatically reply. That was a prank on 2007, and now in 2017, it actually can reply. You can see here in your mobile, when you type it, it will say that there is a possible reply available. So, a period of 10 years, a prank which was told, it's no longer a prank, it's a real thing. And Skype can automatically translate. This was, if you have seen the Hitchhiker Guides for Galaxy, this was one of the science fiction. Okay, but now it is available, like you can use it. And, okay, there's a cut here. Yeah, but actually what you can see in the first one is a original photo which is taken. And on 2013, when this image was trying to generate by a machine, it came like this. But now in 2017, it can ideally draw the exact image. And they tried the same thing for a lot of images in the Louvre Museum, and it worked perfectly. So that means if there is an artist and you want to copy it, you can actually copy it. And surprising thing is, all these things can be done by you with your system, like in a span of like a week time. If you're given it 2 weeks, you can do it. So I'm going to show you a similar code actually, but in the last one. So I'll go one by one. Yeah. So all these things, okay, like whatever I explained, this also came in a very rapid cycle, like the examples which I shown, like you could have seen in an year gap, because email released in a year gap which had this feature. So the reason why this sudden growth of this is because of this technology called as deep learning. Okay, even though everybody calls it as AI and other things, that's just a, what do you call it, like a marketing term. But this is the real technology behind it actually. So that's called as deep learning. And I know that it's a .NET code, so I just want to say what this machine learning is all about. Like, so far what we were doing, so like we will be given a data, that is we have a SQL server or something, and you write the routes and it gives the answer to it. Say a customer information form, the moment you fill it, it gives an answer. But going forward, like what is machine learning in general is, you give the data to it and this is the possible answers I have seen. Say example, like I have pictures of 100 cat images and I say these are cats. Then learn about cats. So when you show the 101th cat to it, it identifies it. Okay? So you don't need to write code anymore. The machine learning will do it actually. So that's the difference. Like that's the shift which has happened so far. And there is a bit of a development which happened in 1 year which I told, right? Like it's because deep learning came into it. Like previously also you would have seen a lot of companies which say that we do predictive analytics. Like we do prediction, all those things. But the problem with the last year or before that was, these predictions are more like this. Whenever there is a Anna Hathaway news came in, automatically the Berkshire Hathaway shares got increased. Okay, it has no correlation, but it took the name and it has no intelligence in it. All that it looked for is, okay, if there is a name there, then can I use it? Okay, it is a statistical model. But that is not how the humans work. So, and if you want to make this exactly how the humans work, then you need a powerful computers to do it. And all like that improvement happened in the last 1 year. There is a set of languages which came specifically to work with GPUs. Like so far, .NET works with CPUs, but now .NET can work with another set of particular hardware called as GPUs. And that made this change actually. It's not just .NET, but it's every language actually. Yeah, so I like to start with a small example. Like I'll give an introduction and then I'll show you a code that runs for most of the image classification problem. So I'll start with the deep learning algorithm. Like these are the libraries which came out in like I can say it's 2 years, and out of which these two libraries, which has changed the whole world right now. Okay, that at least in the space of deep learning, this is changing the whole world. So one is a TensorFlow and another one is PyTorch. Okay, one is from Google and another one is from Facebook. In term like, and everything is C++ and Python based, but there is a C# version for it is available. Okay. There's a C# version for it is available and you can also use it. And in other way around Python, even if you want to do it in a high-end language, like high-end version of it, Python is a better language of choice for it and Python is available for it. And it's not that great a language. You can do it faster, you can learn it faster. Yeah, so like, I'm going to show you a program. Before that I just want to give you just what I did with that program. So basically what I do is like I'll get a data and this part is like you take any data you can get it right now. They call it as open source databases. One example for it is there is a site called as Kaggle. Please once you're done with the session go to this Kaggle site. You can find almost all the data set possible. Like that means
can you spell the site? I mean database?
Yeah, it is not a database, it's a site actually. Kaggle. Kaggle. And it contains even the traffic information of Bangalore, like if you want to avoid it, like what recently open source. And I basically put it in a different folders and we call it as a clean, prepare and manipulate. I'll show you what is the terms really means when it comes to image classification. And I train a model, okay, this sounds like a scary term, right? Like I train a model to do something, but actually it is not. Okay, it's just showing the pictures to it, okay? And the last is I will test it and then I will improve the model, basically give it outside and then it automatically improves on it. Okay. So this is the program which I am going to write actually. Like I'll show some images of cat and a dog and it's going to identify the cat and the dog automatically. Okay. And with that said, like this is the common program which I wrote to show an example, but this can be used for your facial recognition and right now it is the code which I am going to show can be used for cancer diagnosis. It can be for anything. Like recently Intel has conducted a competition for people in Africa. They want to get the cancer diagnosed faster and they have used a similar model what I am going to show to diagnose the cancer and it has won the competition. Okay, so I need to show the code, so I will just move to another system. Zoom out. What is it? Yeah. First I can do it from paper. Just need resolution. Yeah, I see. Yeah, just like that was not So as I told, I will want to show you how to train the cat with this dog problem. As usual, if you go to Kaggle, there is already this problem has data sets and everything prepared. And what I just did was I moved the photos into cat's photos. So as you can see, these are the cats, okay, and dogs. So basically, all that you need to do right now is just you take any face, like take Satish as a face, like have a folder called as Satish and put all the folders as Satish. You have a cancer one diagnosis, put the cancer one diagnosis in a folder. This is all the maximum thing you will do in the image classification problem. And this is a bit tough job actually according to me because you need to download and move it into the folders. And once I move it into the folder, I just name it as cats and dogs to just say that, okay, this is a cat and dog. So basically what I do after that is, like as you can see, there is a code which I written, like I know it's Python, but there is a C# version of it, and it's exactly looks the same. Okay, I just initialize a class called as VGG16. This VGG16 is basically a model which is provided by, I think it's from Stanford, I don't remember it, but there is, this model actually has trained on 1.2 million images of stuff available in the world. So this model is available for you, anybody can use it. So this VGG model, I just say to it, okay, yeah. So what I just did is I just told, okay, this is the folder in the train directory. I have some folders, go look for it. Okay. So what it does is basically goes and looks into the folder and it tries to find. Okay. This is the important thing. Like you can see here, it is saying that I found 23,000 images of 2 classes. And it didn't say what is that. It just told that 23 images are available in two different folders. And there is other 2,000 images which are available. So all that I just do is, okay, go and look for this folder and then just train yourself. So the line which I use here is, you can see here, is a fit. This is the second line of code. So what I just say is, okay, go look for this folder and train yourself on what is there in the folder. So this is enough, and it will go and train itself to get the whole thing actually. And as you can see down here, yeah, you can leave out all these things because it's just a competition file. So sorry for that. Yeah. Yeah, I just ran it once actually because my computer is not that powerful to run it every time. But when I ran it for the one time, it was able to predict accurately, say the 96% of images, it's able to predict it accurately. This is not a powerful system. I just ran it on my system which has just CPU, it doesn't have a GPU. And it is able to say it for 96%. And this is possible for any images. And if I run it, there's some, I'll show you some more blog posts where I show you how to run it on Amazon Cloud actually. And if you run it over there, you can go up to 99% for this problem. Like accurately right now, it can identify cat and dog on a simple images actually. And so there's actually, like, I'll share this code, it is available in GitHub. And so basically it's 7 lines of code which actually does this entire stuff actually. And this is the ImageNet model. Like basically every year there is a competition which ImageNet people conduct right now. It's CADU. So CADU conducts this competition to find the best model which can actually recognize on images. Okay. And there is around 1.2 million images, and for each category, like cat and dog will have more images, like human faces, text, like cars, roads, everything. There is some 1.2 million images of it, and they have trained the model there, and the model is available for you to use it. So now the whole thing, like what we do in AI right now is take that models. So this is the workflow generally happens. You take the input and then find the pre-trained model. So there is a site called as model zoo. If you go to model zoo, it will be like you will see the things available. So what we do is basically we take the pre-trained model, like which is suitable for our problem. Basically, if you are doing a self-driving car, then you need a car which can actually identify a car or an object. So yeah.
The CAD that you told,
Yeah.
is it available for enterprise application development?
Yeah, everything. It's from Google and it's open source.
Okay.
So yeah, but it is
does real-time AI application make use of that?
like define the real time, like
So real-time means, for example, the facial recognition,
yeah,
which our biometric capturing or
yeah,
iris recognition in airports you see or
exactly.
like that.
Yeah.
So do they use that category?
They use it for training because like there is a data set called as Microsoft facial recognition data set, which you can train against all the faces available, possible face.
Okay. So basically, none of the organization builds their own model.
Yeah,
so they basically use Microsoft or Google, someone who is built already.
Yeah, exactly. See, I can't talk for the other organization.
General real time.
Yeah, exactly. Like you can use it. Like if you are a smaller organization, you want to use a model which is already built on it, then obviously you can use it. Yeah. And there is a like different, like when I say enterprise, you are looking for some kind of licensing or something. Yeah, it's open. Like basically you can use it with MSP. Like everything is available. And these competitions are conducted every year. And VGG 16 was the last time Google or Microsoft didn't win. Like even now it is going on. We don't know who is the winner. But 2016, the last year 2016 winner was Facebook. And before that it was Google actually. So basically Google even came up with their model and they told it in their conference. Like they changed their name as AI first. And they told that there is a model which when you take a photo and it actually translates the, like whatever you see it will translate. So that's a model which is, again, it's open sourced. It's available as part of your TensorFlow. And there is a C# version for it also. Just in case if you want to use it. So basically this is the workflow. You collect the input, you look for the pre-trained model which needs to be used, and then you just apply this logic, whatever I just did is basically this part of code, right? It's basically above one things. Because the pre-trained models are done with 1.2 million images, it has a lot of clustering. But I just want only the cat and dog to be recognized. My model doesn't need to recognize the face of a man. So then I just change the code here and then I get out. So this is the workflow right now that is happening. Okay. And yeah, so this is an example I just want to show. So basically this is a, like, leave this diagram out, but think like, okay, there are some inputs which is coming from your video camera or something. And then the second layer, it tries to see, okay, these are the faces I'm getting. Then who are they, like, each layer sees a particular part of it actually. Even they just want to bring down the deep learning stuff down. What it tries to find is, okay, the inner face, like what are the common things which are possible. It tries to bring the pattern, it learns the pattern. It doesn't create anything new. It tries to say, okay, if that's a human face, then I will look for an eye. And then is the eye available? So those kind of things are available. Like those, for each layers of stuff, it will try to do it. But imagine in our case like VGG 16, inside the VGG 16 it will try to do, okay, whether the cat has a curve. So those kind of things it will try to do. Yeah. So at the end of the day, like, this is just a pattern matching thing. Okay. So if you follow this particular stuff, you can also do your own AI stuff like pretty easily. At least I cannot say pretty easily, but it's possible to. Like if you want to recognize. Okay. I just want to say one more competition which came in recently. Flipkart conducted a competition to avoid condense traffic in Bangalore. Okay, and at the result of it, they open source this entire Flipkart traffic data set from BPMP which is available. So now you can actually train a model to find what is the common things which will happen in the routes, so that you can do it. And there is a, like even if you want to start it, there is a small data set which is available from, I don't remember the organization, but they gave what are the kinds of accidents happens in Bangalore. So you can identify what kinds of accident and you can actually suggest, can I use this road? Okay. And this is, sorry.
Can we extract the data from the scanned document? Like, let's say, for example, invoices.
Yeah.
So from that, we can extract the data like rupees, names, and owner.
Exactly, that's what I'm trying on. Yeah, it's possible to. Yeah, it's possible. But actually, that's can't be done with only one model. That's one thing. You need multiple models, but this is an example of there. You can find the model which can do. Basically, you need to, in a short sense, the data which you have to collect is all the images of the receipt, The second is you need to find the model which can understand that's a result. Like you can use VGG for that. There's
That should be an unstructured data.
Yeah, anything.
Not unstructured.
no, it's like if you tilt your images also, it still finds it.
No, not good. Like the levels are unstructured. In the sense, I have multiple invoices from the multiple vendors.
Yeah.
So can it work?
Yeah, I can. I don't have it, but we'll have a different talk. Yeah, I'll show you a demo after that. So we'll go into it. And I just want to conclude with one thing. Like this deep learning is actually done by different types of people. The one first you can see here is Jimmy Herbert. Like he's a very famous Stanford professor. Okay, who's pretty popular in doing this. At least his name. Whenever you go to Google, this name comes when you take deep learning. The interesting thing is there is a 13-year-old Bangalore guy who has a YouTube channel who also is doing deep learning. So, and the last one is there is a YouTube channel fame actually. He is Suraj Rivals, and he is also doing it. So, like I just want to take an inspiration from these days. It's not that difficult for you guys to do. Like you need to get introduced to it so that you can start doing it. And that was my intention of this talk too. And last, this is from a famous person. Deep learning is the internet of this 21st century, and it is happening now. So if you want to catch the wagon, and it's time. Thanks. So, and faster.